everybody, my name is Sophie. Welcome to our April 2023 HSC Standard Maths lecture for ATAR Notes. It is so lovely to be here with you guys today. I'm going to run through a couple of different housekeeping bits and pieces before we get started, but if you are an experienced ATAR Notes lecture attendee, you might notice that our model is a little bit different this time. So no, I'm not live with you today. This is pre-recorded and I'll explain how this is working in just a second. But before we jump into all of that, ATAR Notes, if you are not already nice and familiar with ATAR Notes, become familiar with the next 6 or so months you have left in high school. ATAR Notes is a nationwide company that I work for that is providing these lectures for you today, that provides high school resources to all students across the country. We have a variety of different resources. Head to atarnotes.com/register to learn more. As a bit of an overview for our free resources, we have hundreds of downloadable study notes, live lectures or pre-recorded lectures now that we run 4 times a year. We have our online Q&A for discussions, our videos. We also publish newsletters and articles. We have an ATAR calculator and just heaps more sitting on our website waiting for you to discover it. So head to atarnotes.com/register to learn more. In terms of our paid resources, which is what I would really recommend you have a look at, the first thing we offer is our tutoring through our company TuteSmart, who I work for. We provide online tutoring from elite recent year 12 grads. We have 2 different models. You can have our private tutoring, which is weekly, fortnightly, bi-weekly sessions, hour-long with a tutor, specifically tailored to your subject needs. And then we also provide classes. So once a week, 90 minutes, we have a class for a bunch of different HSC subjects. If you're interested in our HSC Maths standard maths subject, I run that class on a Tuesday at 6 o'clock to 7:30, and it's an hour and a half class covering all of the content in the syllabus for year 12. Highly recommend you check out TuteSmart. Very big fan of it myself. We also have our study guides, which are printed revision materials in a textbook format. And if you'd like to access those online instead, you can go ahead and get a subscription to Ed Unlimited, which has hundreds of top study guides in one place, waiting to help you out. So like I said, all of that will be at atarnotes.com/register. You can head there to learn more. One last thing, I just want to say a special thanks to our university partners who are so graciously helping us put these lectures on for you. So a big shout out to La Trobe, RMIT, Deakin, UTS, and Macquarie University. Okay, so how will this lecture work? If you've been to a previous ATAR Notes lecture of any previous lecture series we've done in the last couple of years, you will know that these are live lectures usually. Usually they're live, they're 2.5 hours long, and I'm communicating with you through Slido usually during the lecture. We have changed this model and it's going to work even better for you guys now because it means that we won't have any technical issues or long pauses where I leave you to work out a question that are a bit annoying to rewatch when you come back. Instead, it is now a pre-recorded lecture with a live chat. So I am not currently seeing any of your messages. I am pre-recording this, but I myself am in the chat right now, checking in with you guys, making sure that everything's going smoothly. So I am still going to be able to answer your questions in the chat. I just won't answer them verbally. They will be written replies in the chat. So this lecture is going to run for 2 hours instead of our normal 2.5. So it'll be a 2-hour lecture. You can ask a question by using the chat. Like I said, I will be active in the chat to answer your questions. I would also recommend downloading the slides, which you can do at any time, and the video will also be available after the lecture. So if you can't stick around to watch the whole 2-hour lecture, the video will remain available. And because we won't be spending any time with silent parts where you work out the question by yourself, it'll just be a nice, easy 2-hour video for you to come back and watch without needing to skip any section or come back and pause certain parts. So that's kind of our new model. I'm really excited about it. I think it's going to work really well for you guys. So yes, please get in touch in chat if you have any questions, anything about the video I cannot change. So if there will be some parts where inevitably my camera might cover part of the content, please shoot a message through the chat if you want me to re-explain what was under the video. If I've accidentally covered something, that's just my mistake. Please let me know. But I can't go slower or go faster or change the pace or go back to a slide. That's not going to be possible today. You can go back to the slides yourself. You can ask me questions. Hey, on slide 70, how did you do that question? Happy to answer via the chat, but I'm not going to be able to do it obviously with a pre-recorded format. So what are we covering today? By the end of today's lecture, we will have covered 2 topics And what we're going to do today is a little bit different, but I think it's going to be very, very valuable to you guys. As you know, or as you should know by now, when you sit your HSC exam in October, about 15% of the content in that exam is going to be based on your prelim content that you learnt last year in 2022. So 15 marks from your HSC exam can be based on or will be based on prelim content. Now, what this means is that a lot of students don't go back and adequately revise their prelim content, and those are actually the questions they get wrong in their Year 12 exam, which is really frustrating, right? Because you spend all this time studying, you nail the Year 12 stuff, but then suddenly something you learn in April 2022, you're being tested on in October of 2023. So how do we reconcile that? Number one, a lot of our HSC materials already include prelim content, just by the nature of them. But number two, sometimes we do some dedicated Year 11 revision. This is super important to make sure we don't have any gaps in our prelim content and we don't go into our exams underprepared, only having revised that 85 marks without going into that 15-mark content related to prelim. So we're going to reconcile that today by looking at two topics and looking at their Year 11 and their Year 12 content. So first we're going to start with algebra. We're going to revise the Year 11 content, and then we're going to look at the Year 12 content in terms of graphical simultaneous linear equations, the break-even point, and modeling nonlinear relationships. Then we're going to go and have a look at statistical analysis in the second half of our lecture. We're going to revise Year 11 content, and then we're going to look at scatter plots, the correlation coefficient, the line of best fit, and normal distribution. Because I am talking for 2 hours straight, there may be a few more water breaks than normal, so I apologize for that. Okay, so a kind of timeline of the lecture. I'm going to give you guys a little bit of an intro to me, who I am, and I'm going to talk about studying for math. Sorry, I've got some form of a dog or cat hair on my face. 2 pets in the house, very hectic. And then we're going to do content block 1, which is algebra, and then content block 2, which is statistics, and then we'll have a bit of a wrap up, and I will talk about some last minute questions I often get and some tips, and then you guys throw me some stuff in the chat and I'll answer them kind of at the same time. So we'll have a bit of a two-way conversation going at the end. So a little bit about me. My name is Sophie, if you didn't already get that. Please, if you're messaging me in the chat, just call me Sophie. No need to Sophie, Soph is fine. No miss or teacher or anything like that. I'm practically the same age as you guys, so no need for formalities. I graduated in 2020 from Bethany College, Hurstville. I had an ATAR of 95.6 when I graduated. Sorry, I have a cat that's going a little bit mental. I studied English Advanced, Standard Mathematics, SOR 1, Studies of Religion 1, Modern History, History Extension, and Society and Culture. So Standard Maths was my best subject. I got a band 6 in Standard Maths. It was definitely the subject, if you kind of look at the range of subjects I studied, it was definitely kind of my break subject. Everything else was writing and humanities, and very much content heavy if you look at those subjects. So quite hard, but maths was definitely the subject that stood out as the break. Now, it didn't mean that it was always the easiest subject, and I would say that a lot of people kind of misinterpret that standard maths is going to be really easy. It's not always going to be easy, and I think you guys hopefully know that by now. But like I said, I did get a band 6. I feel like I'm decently qualified to talk to you guys about it. I am currently studying a Bachelor of Arts and Laws at the University of New South Wales. If you have any questions about uni, I would say you can let me know in the chat and I can answer them in the chat if I have time and if it's not too busy. But let's keep our questions more related to Year 12. Again, happy to answer them if I have the time, so drop them in there. But if you feel like it's not, if you're just looking for something to ask or something, try and keep it to Year 12 content, Year 11 content. Again, happy to answer them though. But yes, Bachelor of Arts Laws at UNSW, loving it there. Really do like UNSW if anyone's thinking about going there, and do like my arts and laws degrees if you're thinking of studying those. I have a beautiful German Shepherd. Her name is Luna, and I mention her because she likes to make audio appearances via some barks occasionally, so I apologize for that if it does occur. I like to throw in the little teacher's pet but in a cool way thing, just to say that it is cool to care, and it doesn't matter if you feel like you're putting in too much effort or people say that you're trying too hard. You should be proud of the hard work you're putting in, as long as it's to a healthy extent. And so I would say you being here today, I'm super proud of you, putting in a lot of effort, and it's really nice to have you guys here very dedicated today with only, honestly, about 6 months left. It's going to go by very quickly. A couple more points. I also guarantee that I procrastinate more than you. I know that you don't think it's possible, but it is. I promise it is. I've only met a few people who are worse than me, but I'm pretty bad. So if you do have any questions about procrastination, because I get them every single time I lecture, please just pop them in the chat and I will be happy to answer them. But I'm going to talk a little bit about procrastination at the end of the lecture as well. One of my non-academic tips for the HSC is to plan something really amazing for afterwards. I went on an amazing camping trip. It was an amazing, I keep saying amazing, it was a great thing to look forward to. It really kept me going in those last couple of months, knowing that I had a really great trip to look forward to. And I would recommend it just to set up something that's going to be an incentive for you, that's going to keep you engaged and keep you excited about finishing year 12, because you don't want to just finish year 12 and your only reward is that it's over, right? You deserve a bit more than that. So set something up for yourself. It doesn't even have to be money related, just something that is going to make you happy and give you something to look forward to at the end of year 12. So how am I supposed to study for maths? Now, I know that this says start now. It would be much less overwhelming if you do some groundwork early on, but I say start now because even though you're, well into year 12 and you're about to finish, or you're finishing term 2, there's still a lot of work you can do now that will save you a lot of time when you get to trials later on. It's not a case of you should have started 6 months ago. It's a case of what can you do now. It's much less overwhelming if you do some of the groundwork for your trials and for your HSC now by creating summary sheets, by doing practice questions, by doing chapter reviews, by doing practice exams now, rather than just learning content and then banking on all of that content coming back to you in, 2 months, 3 months from now when you start to do practices for your trials. So starting now via the next step is very important, given the next step is to keep a rule book or to write summary pages. So you need some form of note-taking in maths. Note-taking in maths is definitely a bit of a kind of it depends question. It depends how you work. I would recommend you do need some form of notes, I would say, very, very minimal. And all it really needs to be, in my opinion, is a summary page or a summary sheet that has the formulas on it that you need and the key diagrams and information that you're required to answer questions. So you don't need to write very extensive notes about how to answer questions or step number 1, find this, step number 2. If that works for you, that's great. You just need something that will help you answer questions while you're practicing. Now, I want to make you guys aware that when you sit the HSC, hopefully you know this by now, this piece of paper will be put on your desk next to your exam. It is the reference sheet, they call it. It's also, you could call it a summary sheet or a formula sheet. And it has 3 different sections: financial, measurement, and statistics. There's no need for anything networks or algebra related. And it gives you 3 different sections that have formulas or references on them. So you have a bunch of different stuff in there. Does this constitute your notes? No. You need to be doing more than this when it comes to note taking and it comes to remembering formulas. I apologize. My cat's going a bit mental. I'm just trying to... She'll be good. So you can't just rely on this to be your summary sheet. You will have to write your own formulas and your own practice to use in your own time. You can't just use this when you're practicing because it doesn't have everything on it. Another important note that I want to reference about this sheet is that if you take a look at a lot of things like the formulas or your trigonometry formulas, they're not actually telling you what they are. They're not actually saying, okay, where it says A equals theta over 360 times pi r squared, it doesn't actually tell you what that area is. You need to know that that's the area of a sector of a circle. So it's very important that you guys understand this stuff in a way that is not just reliant on you having this sheet in your exam, if that makes sense. The next thing that I would say is to make sure that you figure out what you need help with and target it. So you need to make sure that you spend time on things that you're struggling with, but don't disregard everything else. Now, this means that if you get an exam back and you lose a certain amount of marks in a certain section, you need to make sure that that section, if you lose 10 marks in the algebra section and you've lost 2 marks in the statistics section, yes, you need to revise statistics at some point, but you need to focus on that section, which I think I just said was algebra, a little bit more than the statistics. Now, I know that they say you need to break down all of your subjects and have them all be equal, which is true in a sense, but you need to make sure that inside of maths, you're not giving exactly equal time to the 5 units just because there's 5 units. You need to be giving time to the ones that you're struggling with the most. Now, I kind of have a bit of a story about this where because I found simultaneous linear equations quite easy and I understood them quite well, I would do them more often than things that I struggled with, like bearings or trig, because I found them quite satisfying and I knew that I was going to get 80 to 90% every time I practiced them. And that was like a good kind of motivation for me, because I was like, oh, okay, well, I'm getting good marks, like this proves that my studying's working, blah, blah, blah. But I was ignoring pieces of content that I knew that I didn't know how to do, and I knew that I was going to lose marks on in the exam. So it's very important that when you figure out what you need help with, that becomes the target of your revision. It's also important that the revision is active and not passive. So what I mean by that is that there's kind of 2 types of revision: active revision and passive revision. So active revision is revision that actively targets the content and is an active form of addressing it. So reading your textbook is passive revision because you're just passively engaging with the content. Active revision will be keeping a rule book, making a summary page, doing a practice exam, doing a chapter review, something like that. So it's important that you have active revision on the things that you need to target. Another thing I would add here is that there's always going to be someone who can help you. Number one, your teachers are literally being paid to help you, so please ask them questions. They're paid to answer your questions. If you aren't finding that that's helpful enough, go to other teachers that are at your school. Go to your friends and your classmates and see if they understand the piece of content. Check out our resources, see if tutoring is the right option for you. It could be that you need private tutoring, or you need to engage in a class model, or you need to engage with some of our summary sheets or our notes. And then always you can Google, use YouTube, find videos online, find resources from people, find practice exams that have solutions. There's always going to be something that can help you understand a piece of content. This next one is a bit interesting in terms of how to apply it. When I say study with friends, it's very much, again, it depends if this works for you or not. The first way I would recommend studying with friends is actually not in person. I would recommend studying with friends over FaceTime or over a video call. Number one, it's less easy to get distracted because a lot of the things that create distractions when you're actually with friends are when they go like, oh my God, look at this, or you see something and you're talking about the same thing, you're together, or you're outside, you're at the library and there's a lot of things around you to stimulate you. When you're at home sitting at your desk in your familiar environment and they're just on FaceTime, it more acts as a kind of model of you're both focusing, you're both working, and you're keeping each other accountable. And it's less exciting basically. Whereas if you go and study at a library and you bring a whole friend group, there's let's go get food, let's go walk around, let's go talk to the people we know, let's go outside, and it turns into a more distracting environment. It doesn't mean it can't work. I'm just saying when you study with friends, you do need to have kind of a disciplined approach to it, where you can't just say every time you're going to go study, I'm going to go study with friends, and then you get nothing done. Again, it's your prerogative, do what you want. That's my advice on that. The last thing I would say is please take care of yourself. These next few months are really going to be intense academically, but it's very important that you don't neglect your mental and physical health at the same time, because if those two suffer, your understanding of the content and your ability to take in the content and apply it to exams will suffer as well. So it's very important that those things kind of strike a balance. Again, that's very difficult to achieve. And it's very much easier said than done, but it's advice that I would say is honestly, of the list of 6 things that I put on this slide, it is the most important. Again, easier said than done. Feel free to ask questions in the chat about how you think that's best applied, but that would be the piece of advice I would say is the most valuable. So I want you guys to let me know in the chat right now, what topic would you say that you struggle with the most? Is it algebra or is it statistical analysis? Again, I'm not going to be able to see that in real time, but it does help me in the chat kind of understand where to expect an influx of questions and where you guys are maybe going to have more difficulty taking in the content. Give you a minute to do that. Okay, Let's jump into our first content block, which is looking at algebra. We're going to start with some Year 11 content that you are assumed to know. So this is a quick note that I said before. You might not have realized it will be examined in the HSC, but it definitely can be and it will be. So we're going to recap two parts of the Year 11 syllabus from algebra. We're going to look at formulae and equations, and we're going to look at linear relationships. Okay, so formulae and equations. You should be confident so far with the basics of algebra. Now, what does this mean? We kind of have two things here that I want you guys to be thinking about. The first one is substituting a number into an algebraic expression or equation, and the second is changing the subject of the formula. These are two foundational aspects of algebra that will form the basis of a lot of questions you'll receive in the HSC and in Year 12. Just because they're prelim knowledge doesn't mean they won't form the basis of those questions. We're going to have a look at some examples. So substitution. Substitution, if you don't remember from Year 11, is when you take one part of a formula. Let's say we have 5 equals x plus 2, and you are given a piece of information and you substitute it into the formula. So x equals 3. Let's have a look at this example question. Given that I equals 3 over 2 times m times r squared, what is the value of I if m equals 26.55 and r equals negative 3.07, correct to 2 decimal places? So what I'm going to do is I'm going to write out my formula. I equals 3 over 2 times m, which is 26.55, times r, which is negative 3.07 squared. And all I need to do from there is put that into my calculator. So 3 over 2 times 26.55 times negative 3.07 squared. And I get negative 375.35 to the nearest, well, it's 0.346, but I'm going to round up to 35. We can see it's under there. And because we need to put brackets in here, when we put that into it, sorry, I put it into my calculator, but I didn't draw the brackets on, we should have 375.35. So it's important that you separate out things like this, the times and the negative, otherwise you'll get the incorrect answer. And you can also put the squared on the outside of the brackets as well. And like we said, it was 346, so we need to round to 35. Okay, example question. We have make y the subject of the following equation. So this is the second part. That was substitution. This is changing the subject of the equation. When we change the subject of the equation, I first want to identify what the subject is. So say we have the equation y equals mx plus b, which hopefully you're familiar with by now. The subject of an equation is the answer, the part of the equation that is found with the equation. So the subject is usually the shortest side. I can't think of an example where it would be the longest. And this is a very weird question. And when you're asked to change, they're going to say, make something the subject of the equation. So put it on the smaller side of the equal sign, basically. Make y the subject of the following equation. So step number 1, what is the current subject? The current subject is negative 2x. We want to make y the subject of the equation. So negative 2x minus 3y plus 4. The first thing I'm going to do is move the easiest part of my equation over. We're going to do that by subtracting 4 from both sides. So now we have negative 2x minus 4 equals 3y. Now, if I want to get y on its own, we can't leave it next to a 3. We have to get y by itself. I'm going to do that by dividing each side by 3, which leaves me with y equals negative 2x minus 4 over 3. And if we, I don't have that formula in there or that working out, but as we can see here, using fractions instead of the division sign like this makes it a lot easier. So that is what our formula, that is what our example would look like once we've changed the subject. Another thing we're going to have a look at with Year 11 content is our linear relationships. So when we did Year 11 in prelim, we learnt about the two forms of equations that we have to represent a line. The first is y equals mx plus c. So this is point gradient form. It's telling you that a point on the line is 0, c. This is the y-intercept. So remember, our linear looks like this. This is our y, and it's 0 something. So it's on this part of the x-axis, but it's going in at some point on the y. It's also telling us the gradient of the line, which is, if this is our line, this is our gradient, how steep it is. If it's a really steep line, if it's a really shallow line, if it's almost vertical, if it's almost horizontal, whatever it is. So ax plus by plus c equals 0. This is the second form. This is a general form. So it's much easier to graph lines if they're in the first form, which is basically the only one you actually end up using, which is why it's important to know how to change the subject, because sometimes we get them in the general form and we have to put them in the point gradient form. So for example, solve 7x minus 4 equals 32. We're going to jump back to some questions now. So I know we've got the working out here, but the first thing I would do, 7x minus 4 equals 32, is I would add 4 to both sides to get 7x on its own. Now that I have 7x equals 36, I'm just going to divide each side by 7 to get x on its own. X equals 5.14. We have another one here. For example, solve 8x minus 9 equals 79. How am I going to do this? Same thing as before. 8x minus, that's a horrible x, sorry guys, minus 9 equals 79. We're going to add 9 to both sides to get 8x on its own, 87. And then we're going to divide each side by 8 to get x on its own. So x will equal 87 divided by 8, which is 10.875, which we can round up to x equals 11. We can also deal with linear equations and substitutions, those two things we just spoke about, at the same time. So given that y equals 6x minus 3, find x when y equals negative 18. So how do we do this? Y equals 6x minus 3. How are we going to find it when y equals negative 18? So we're going to substitute negative 18 into our formula. So y equals negative 18, which then equals 6x minus 3. So now we want to find what x is. The first thing I'm going to do is move my 3 over by adding 3 to both sides. So add 3 here and it ends up cancelling itself out. Add 3 here and I end up with negative 15 equals negative, it just equals 6x, sorry. And now I just need to divide each side by 6 to get what x equals, which we get x equals, now you can write negative 2.5 like I've written over here, or you can write 2.5. Here's another example, which is substitution and linear relationships together. Given y equals 7x plus 11, find x when y equals negative 5. So we're going to substitute in our value, which is y equals negative 5. We're going to put it there, equals 7x plus 11. Now, what was our first step? We're always going to move the number that doesn't have a pronumeral. It's the easiest to move, which is 7x has a pronumeral, 11 is a whole number by itself. We're going to subtract 11 from each side. Negative 5 minus negative 11 is negative 16 equals 7x. And we just divide each side by 7. Negative 16 divided by 7. X is equal to negative 2.28, or we can just write 2.29 to round up. Given that, hang on. Oh, let me double check my working here. Negative 5 plus negative, negative 5 minus negative 11, negative 16 equals 7x divided by 7. Yeah, there's an error with the working out on this one. So I think go with the one I've just written down. I think what would have happened is the answer is probably written without the negative 16. The last part of formulary and equations from year 11 that we're going to cover today is travel calculation. So this is our whole speed, distance, time, stopping distance. Now, all of these things may be on your formula sheet. Now, when we have a look at it, They're really not. They might be on your formula sheet for certain things in your like internal exams, but they're not going to be on this final formula sheet. So you do need to know them. So this triangle, anytime you see a red rectangle, it's very important. You need to understand what's in it. This triangle is your key to remembering speed, distance, and time calculations. So it goes as follows. Anything up here, so this is representing a fraction. This is representing a times. So speed is going to be distance divided by time. Distance is going to be speed times time, and time is going to be distance divided by speed. Following, very important. I'm going to give you guys a second to screenshot that. Okay, let's have a look. First thing I'm going to do on any question that is about distance, speed, or time is I'm going to come here and I'm going to draw my triangle. Distance, speed, time. A car travels 86 kilometers over 1.5 hours. What was its average speed? So speed is equal to distance divided by time. Our distance was 86 kilometers. Our time was 1.5 hours. Therefore, the average speed, 57.3 kilometers per hour. We would likely represent that as 57 kilometers per hour. Another example. Let's draw our triangle. A person runs for 2 hours at 4.3 kilometers per hour. What distance did they travel? Distance is equal to speed times time. 2 hours times times 4.3 kilometers per hour, which is our distance, is going to give us 8.6 kilometers. What distance do they travel? 8.6 kilometers. A car can travel 80 kilometers an hour. How long will it take to travel 56 kilometers? Let's go distance, speed, time. Time is distance over speed. A car can travel 80 kilometers an hour. How long will it take to travel a distance of 56 kilometers? We have to divide by the 80 kilometer an hour speed. We get 0.7 hours. So you would write roughly 42 minutes. How do we get down to that? You can just do 0.7 times 60, which would give you 42. It's very important to always remember there's only 60 minutes because a lot of students get that wrong and they go with the 100 and then you write down the wrong minutes. Okay, we finished our year 11 content. We are going to jump into our year 12 content for algebra. The first thing we're going to look at is solving simultaneous equations by drawing a graph. Now, when we solve simultaneous equations, we have two methods we can solve them, graphically or algebraically. We're going to talk about graphically. So here's an example question. Solve the simultaneous equations 2x minus y equals 4 and 6x plus 2y equals 12 graphically. So how are we going to do this? To answer this question, we have to graph both of these equations as straight lines, and we're going to use the point gradient form. Very important. We're going to use y equals mx plus c. Y equals mx plus c. Very important. So we're going to rearrange each equation to match this formula. So how are we going to do that? The first one we have is 2x minus y equals 4. Now we need that to match our formulas. Now you guys can't tell me how to rearrange these. Feel free to write them in the chat how you would rearrange them as I work through them. But I'm going to run through the working for you now. Actually, we'll do it on this slide so you don't see the working straight away. So the first thing we need to do is get y by itself. So actually I might run through it here. We're going to remove the 2x from the front and put it to the back by subtracting 2x from both sides, which ends up leaving us with negative y equals 4 minus 2x. We then need to times each side by minus 1 so that we just have y. We can't use negative y in a y equals mx plus b format. This cannot be a negative. That will be incorrect. It has to just be y. So we're going to times everything by -1 to get a positive 2x, -4, and a positive y. Other side, 6x plus 2y equals 12. We're going to move the 6x by subtracting it from both sides, which leaves us with 2y equals 12 minus 6x. Now we can't have a 2y. Again, look at our formula. Y equals mx plus b, not 2y, y. So we're going to divide everything by 2 to get just y equals -3x plus 6. Okay, I'm going to show you the step-by-step working of this question. Please do it with me. We're going to go over it over a couple of different slides. Okay, so number 1 is set up your page. I'm going to give you guys a couple seconds to get some form of paper in front of you and have some axis drawn. So you need a vertical axis and a horizontal axis. And I want you to pop some markings on them and label one as X and one as Y. Horizontal will be X, vertical will be Y. Okay, so once we've done that, we want to have some markings on them. Now going back to our formulas, notice that the numbers are quite low, 2, 4, 3, and 6. We don't need a high axis. We're going to go to 8 on our vertical y-axis, and we're going to go to 4 on our horizontal x-axis. Now, it doesn't have to be the same on each. It just has to be the same on the entire x, and then the same on the entire y. X and y don't have to work on the same intervals. Okay, so we're going to graph the first line. Y equals 2x minus 4. First thing we're going to do when we graph a line, which part is the y-intercept? Y equals mx plus b. -4 is the y-intercept. -4. Now we're going to use the gradient to mark 2 or more points from the y-intercept. So our gradient is 2, which means that the rise over run, for every 2 points we rise, we only run 1 point. So I'm going to rise 1, 2, run 1 point. 1, 2, 2, run 1 point. 1, 2, see how this is 2? And this is 1, run 1 point. Now we have a bunch of different markings on our linear model that represent a rise over run. Remember, if your gradient is isn't a fraction, whatever number it is, it's over 1. If your gradient's 4, it's 4 rise, 1 run. If it's 5, it's 5 rise, 1 run. When you do this, you have to be careful. Just because this is only one box and this is only one box, it doesn't make them even. That is 1, but this is 2. So you have to pay attention to what these intervals are. So we draw a line. We now have a line, y equals 2x minus 4. Now we need to mark the second line. We're going to find the y-intercept of our line. So let's go back here. What was the y-intercept? 6. So we're going to go on. We're going to mark 6. What's our gradient? -3. Now what's the difference with gradients? Some are positive, some are negative. This is a positive gradient, the one we just did before, because it was a positive 1, or 2, sorry. This is a -3. Negative gradients run from top left to bottom right. So now we're going to mark points where we go 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So 3 rise, 1 run. So we're going 1, 2, 3 across 1. 1, 2, 3 across 1. Very important. Each of these little triangles will create the same gradient, which is a rise of 3 and a run of 1. 3 over 1, it's a negative. -3 is your gradient. And now we draw those two lines. The final thing we need to do, we've drawn our two lines, is find the point of intersection to solve them. The point of intersection here is 2x, 0y, because this is 0y and it's on 2 positive x. So we write 2, 0, and we put it in brackets. So now that we've used this information, we can substitute these numbers into our current formulas to double check they solve each equation. So our point of intersection was 2, negative 0. Let's have a look at our first formula. So our 2 was the x, y was 0, so we sub that in. 2 times 2, we're going to put that in brackets, minus 0, which is where the y was, equals 4. Is that true? Yes. The next one, 6x, which is now 2, plus 2y, which is 0, equals 12. Is that true? Yes. So we've substituted our point of intersection of the two lines, which is where the lines are solved, into our original equations that we didn't change into y equals mx plus b. We've substituted in 2x, y 0, and the equations still work. Okay, we've now solved this equation. X is equal to 2, y is equal to 0. Okay, now it's your turn. Solve the simultaneous equations x plus y equals 10 and y equals 2 plus 3x graphically. So here are your key steps. Number 1, rearrange the formulas to fit y equals mx plus c. 2, graph them using the gradient and y-intercept. 3, find the point of intersection, which is your solution. And 4, check your answer. So I'm going to give you guys 30 seconds to jot that down, and then we're going to go through the solution. If you need more time to attempt this question, that's fine. Based on the pre-recording of the lecture, I'm not going to give you guys too much too much silence for me or time to work stuff out, because you can come back and do it. I want to give you guys as much explanation as I can. Okay, let's go through our key steps here. So the first thing, we're going to rearrange the formulas to fit y equals mx plus c. So y equals mx plus c, remember it could be plus b or plus c, both are correct. X plus y equals 10, y equals 2x plus 3x, y equals 2 plus 3x, sorry. So how are we going to get y on its own? We're going to subtract x and add it to the other side. Then we have y equals 10 minus x. How are we going to get this worked out the right way around? No need to change. It's already correct. It doesn't matter that the y-intercept comes before the gradient, because they're still both present. Now this step should at the beginning take about 5 minutes to do. By the time you get to your exam, hopefully you're more like 3 minutes on this step, but you're going to graph them using the gradient and the y-intercept. The last step is to find the point of intersection. So if we have a look at our two lines, we should be able to see that one of them was a positive gradient, if we look back here, and one of them was a negative gradient. This is a negative gradient, negative 1x. The gradient was negative 1. This gradient was 3. This y-intercept was 10. This y-intercept was 2. Have a look at these and see where each of those pieces of information come in. So now that we've had a look, let's run through how we find our point of intersection again. Sorry guys, I felt a sneeze coming on there. I didn't want to cut myself off halfway through. So let's look at each of our lines. Let's take a guess of which one was which. We have an intersection of 10 on the blue one. I'm going to assume that's y equals 10 minus x. And this one we have y equals, let's have a look back, 2 plus 3x. Those are our two lines. The point of intersection, we need to find what x point it's on. It's on x2. We always write x first. It's on y8. 2, 8, we put it in brackets. Our point of intersection, our solution. Now we double check our answers. X plus y. X was 2, y was 8. Yes, it equals 10, correct. Y was 8 equals 2 plus 3x. X was 2. 8 plus 2 plus 3 times 2. Yep, correct. These are both correct. So we know that this point of intersection was correct. I'm going to give you guys just a second to write that down. Okay, let's have a look at some practical problems that we can apply simultaneous equations to. So what does break even mean? Break even mean. What does break even mean? Okay, there we go. When we look at these practical problems, we look at all these lines, look at all these graphs, what do they even mean? This is a very common graph that uses two graphically plotted simultaneous linear equations to graph profit and loss and revenue and costs and sales and units and all of that stuff. So when we look at these kind of financial graphs, we refer to the break-even point as the point where costs equal income. So say you produce appliances, right? And it costs you a certain amount of money to produce appliances and you sell them for a certain point. At some point, the amount of money that you spend producing them is going to meet the amount of money that you've made selling them. That's your break-even point. That's the point where the money that has left and come back into your bank account is technically zero. You've spent the exact same amount of money that you've made, so you haven't made a profit or a loss. Below that point, it will either be a loss, or above that point, it will either be a profit. So this is an example question from one of our books, an Unlimited Standard Maths book. Archie organizes a fundraiser for Beyond Blue. The fixed cost is $2,000, as well as an additional $20 per person who attends. Each person attending pays $60 per ticket. Draw a graph to represent these equations. A, what is the break-even point and what does it mean? And B, how much profit is made when 80 people attend the fundraiser? So before we even attempt to draw our graph, which have a look, we're looking at the fixed cost of $2,000 for an additional $20 per person who attends, and each person is going to pay $60 to attend. We need to find the straight line equation for both sets of information. So we're going to write out two equations. The first one is equation 1. This is the cost of the fundraiser. So the setup cost is $2,000. Now, why is this the y-intercept? Because before the fundraiser even happens, he will have spent $2,000. So if this is our line, right? Which with these graphs, we actually just start on this side of the line, positive, we don't have any negative. We're going to start at $2,000 because you're not spending zero and going up. You're literally spending $2,000 off the bat. Then there's the additional cost of $20 per person. That's our gradient. So our first equation is going to be cost equals 20 times the number of people who come, which is x, and representing our gradient, plus 20 is our gradient, x is representing the number of people who come, and $2,000 is our y-intercept, our fixed cost. The second equation is the income earned by the fundraiser. The income earned is $60 per person, which is just going to be I equals 60x. No need for a y-intercept. So this is what our graph would look like. Now, why don't we have this one, or this one? Because there is no negative amount of income. There's no negative number of people attending. So there's no need to have anything except this quarter. Okay, first equation. Find the y-intercept in the gradient and rule up the cost line. So the total cost was $2,000 off the bat, and then we rule in how much it's going to cost per person. So if 10 people come, it's going to cost an extra $200. If 20 people come, it's going to cost an extra $400, so on and so forth. So you usually want to plot about 4 to 5 points and then draw a line through all of those points so you get a very accurate line. The next thing is I equals 60x, our income formula, which is I equals 60x because it's $60 per person who attends, and x is the people who attend. So we're going to start at 0 here. We're going to draw a straight line based through all the points that we draw. Now we should recognize what that is. That's our point of intersection, our break-even point. So everything below that point in here, this is all loss. This is where the fundraiser makes no money and is actually losing money. This is all profit. So our break-even point is 50 people or $3,000. If 50 people attend, we will have spent exactly $3,000 and made exactly $3,000. Okay, so we can plot it out and say this is profit, this is income, cost. It occurs when 50 people attend. So we need to go back and answer our questions. What is the break-even point? What does this even mean? The break-even point is when 50 people attend. When 50 people attend, the cost is $3,000 and the income is $3,000. If more than 50 people attend, he'll make a profit. If less than 50 people attend, he'll make a loss. We're going to check this answer using both equations. So we've established on our graph that the break-even point occurs when there are 50 people attending. So now x equals 50. So we're going to substitute in 50 and we get $3,000. And when we have I equals 60 times 50, we substitute in here $3,000. Both of those equations are correct. So B, how much profit is made when 80 people attend the fundraiser? It's important to remember, profit will equal income minus the costs. We therefore need to calculate the income when 80 people attend and minus the costs of 80 people attending. So income when 80 people attend is 60 per person who attends times 80 people, $4,800. The cost of 80 people attending is going to be 20x plus 2,000. Remember, that's our upfront. That's how much it costs per person. Substitute in 80 is going to be a cost of $3,600 to run the fundraiser when 80 people attend. Okay, hopefully we're all following so far. So we're going to calculate the profit. Profit equals income minus costs. We subtract 3,600 from 4,800. We get $1,200. So if 80 people attend his fundraiser, Archie will raise $1,200. Okay, here's an example question. A footwear company produces items whose costs are $300 plus $18 for every pair of shoes produced. The company sells the shoes for $110 per pair. Write an equation to represent the relationship between the cost and the number of items and the income and the number of items. Okay, so the first thing we're going to do, and I'll just check if I've written out my solutions here, yeah, is write our two equations. Cost is going to be $18 for every pair of shoes produced, the X, plus $300, which is just an upfront cost. The income is going to be $110, which is the cost of purchasing the pair of shoes, times the number of shoes that are purchased. We now need to draw these onto a graph. So have a look at our y equals 18x plus 300. This is our cost. Our intercept is 300. We draw out a line for $18 per cost of each pair of shoes being developed. Our income always starts at 0 because you don't have any intrinsic income, times 110 for every pair of shoes sold. Now we can find our break-even point in here, which is a little hard to see, but it's about 3.5. You can't sell 3.5 or 3.25 pairs of shoes. You need to round up so that it's 4 pairs of shoes needs to be sold for the company to break even. This is the last part of our algebra learning, so we should be finishing up relatively soon and we'll move on to statistics. We're going to look at modeling nonlinear relationships. So we're having a look at exponential functions, quadratic functions, and cubic functions. So an exponential function is a nonlinear curve whose equation has an x or some variable as the power. So we look at these functions that have a little number next to have a little x or something next to our number. So the general rule is that y will equal ax. I know this is just kind of gibberish, but stick with me. Exponential functions are used to solve growth or decay problems. So think about the spread of COVID, bacteria growth, all of those questions that involve stuff that exponentially grows or decays. So here's an example question. The growth of a certain bacteria is estimated according to the formula B equals 10 brackets 2.1 close brackets t, where B is the number of bacteria after t hours. A lot of these function questions are basic substitution questions or changing the formula. They aren't actually that complicated. So the first thing we have to do, construct a table of values to represent the growth of bacteria up to 12 hours. The second thing is to draw a graph representing this information. We're going to go through these two questions first. So to construct a table of values, we have to recognize that what the x is and what the y is in this question. So we're looking for the growth of bacteria, which is dependent upon the number of hours. So therefore, if the growth is dependent on the number of hours, the bacteria growth is the dependent variable. Time, which is just going to pass regardless, is independent. So it's going to go on the x-axis. Good way of thinking about this is HIV, horizontal independent variable. It's usually as well, the hot tip here is that the power is the x value. Okay, so remember the formula is b equals 10 2.1t. We're going to use intervals of 2 hours in our table of values. You can do the same or you can do every hour. If you want to find, remember t was time. If you want to find the growth after 2 hours, you just put 2 hours in. So after 2 hours, there's going to be 44.1 bacteria. We're going to do that for all of these periods of hours. So if I wanted to find it for 6 hours, b equals 2.1 to the power of 6, which would equal 858. If I wanted to do it for 12 hours, b equals 10, 2.1 to the power of 12, which equals 73,588. Now we plot these values on a graph to answer the second part. So this was done online to make it really easy to understand. It would be difficult to accurately plot these points because we start with 10 and we're at 76,000 or 74,000 practically. You can insert the data into an online graph maker to help you understand the shape so you can answer questions, but they're not going to ever give you questions that you can't plot. This is just one that would be hard to plot. Okay, so we need to understand our graph. The growth of a certain bacteria is estimated after that formula. What was the initial number of bacteria? What was the number of bacteria after 9 hours? And how long would it take for bacteria growth to reach 35,000? How would we answer these? C, the initial number of bacteria was 0 because when was 10 because when t equaled 0, we already had 10. Now let's look at our formula. B equals 10, and then this is our function where our hour comes in. So we've already got 10 bacteria. The initial number of bacteria is 10. To calculate it after 9 hours, we do what we just did. We'd put 9 where we put our t, 7,943. All right, E, estimate the time taken for the number of bacteria to reach 35,000. We have a look here, 35,000. We track all the way over. We go down. That's about 11 hours. And I apologize if that's under the video, but it'd be about 11 hours. Okay, we're going to have a look at quadratic functions. A quadratic function is a nonlinear curve whose equation has an x as an x squared. So it's very important. The distinguishing thing about quadratic functions will be the x squared being present. The general rule for this function will be y equals ax squared plus c. You can think of it almost like y equals mx plus b. A and c are going to be numbers, and x squared is going to be its own part of the equation. So this is an example of a quadratic function here. So to distinguish a quadratic function, we want to recognize the shape of the graph as a parabola. People also call them a parabola, but it's a parabola. It always has a turning point and an axis of symmetry. They're very, very distinguishable because they always look like this. So very important, I'm going to lose the ability to say the word. A parabola that has a smiley face is a positive gradient. So smiley, good, positive, yay, everything's going right in the world. Parabola, forgive me, I've lost the ability to say parabola with a sad face has a negative gradient. So boo, sad, not good, it's got a sad face. So you can see ax squared plus bx plus c is a positive. See how it's a positive, negative here, frown. Important tip to remember, put that on a summary sheet. So example question, complete the following table of values and graph the quadratic function. So y equals x squared minus 4x. So we're going to insert some x values to find some example y values. We usually just use a range around -5 to 5, something around that easy small number range. Because it's a positive, I'm just going to stick to mostly positive numbers because it will go in the inverse. Now we're going to graph this. One important thing I want you guys to notice about parabolas. Numbers are going to repeat and they're going to mirror, right? This is how we know it's a parabola. The turning point is going to be the number that isn't repeated, which is -4. So the -4 is going to be our turning point. When x is 1, y is -3, so that's there. When x is 0, y is -0. or y is 0, when x is 0, y is 0. So actually, I'll show you guys the other ones first. That'll make more sense. When x is 1, when x is 2, y is negative 4. X is 2, y is negative 4. When x is 1, y is negative 3. When x is 2, y is negative 4. When x is 3, y is negative 3. We go about here. When x is 4, y is 0. When x is 5, y is 5. X is 5, y is 5. We come back around here. When x is 0, y is 0. When x is negative 1, y is 5. Now we see we can follow our line around to create a parabola that looks like this. Our turning point is negative 4, and all of these points mirrored each other. Okay, the last thing, I think this is the last thing we're looking at, yeah, should be, is cubic functions. A cubic function is a nonlinear curve whose equation has an x as an x cubed, i.e. x3. So this is very important. Think about cube, right? Cube, we do centimeters cubed, meters cubed, kilometers cubed. X cubed, cubic function. Okay, the general rule for this function is that y equals ax cubed plus 3. So virtually the same. What I want you guys to recognize, cubic functions look like these little waves. They don't mirror like parabolas. So here's an example question. An ant population is predicted using the formula n equals 100t cubed. We know this is cubic because it's a cube, where n is the number of ants and t is the time in days. Draw the graph of n equals 100t cubed using a table of values. How many ants were present after 1 week? Use the graph drawn to estimate. We're going to construct a table of values like we did earlier. The dependent value is the number of ants because it depends on the time in days. So y is the dependent value, the number of ants, and x is the time in days, t. So to find the number of ants after 2 days, we're going to do the formula. We're going to substitute in 2 as t, and we're going to use our cube, 800 ants after 2 days. We do that for 6 different data points, 0, 2, 4, 6, 8, 10. And now we can construct this in a graph. So see how exponentially it immediately goes up like this. And there is no chance that it's going to go like this, unless there's an intervening factor. So this is thousands. So after 2, there's 800. After 6 days, there's 21,600. After 10 days, there's 100,000. So see how we've signified that it's thousands. Thousands on the side there. Okay, so by using a graph, we can now answer question B. To estimate the number of ants after 1 week, we need to determine where the nonlinear curve passes 7 days. So where are we hitting 7 days? So this would be 35,000 ants by kind of looking at our, if we track up and go to about here, well, a bit better than that, we'd be about here, 35,000 ants. But we can test that in our formula by going 100 times 7 days cubed, 34,300 ants. So 35,000 ants is approximately correct. So the graph we just drew, like I said, looks very similar to exponentials. However, it's important to highlight cubic functions can go through the point 0, 0. Exponential functions do not. What I mean by that is exponential functions always start like this. They never start from 0, 0 because they're always growing from something, right? Okay, which graph best represents the equation negative 2x3 cubed plus 3? Now, why is it A? This does not pass through any other quadrant of our linear. This does. This is what a cubic function is going to look like. It's going to pass through multiple quadrants. Now let's have a look at our point as well. Our y-intercept is plus 3. Plus 3, we're not intercepting y there. That would not be a cubic function in regard to that equation. Okay, that brings us to just over an hour in, and we have wrapped up our algebra section. We're now going to jump into the second half of the lecture, which is statistical analysis. I'm just going to give myself a quick water break and we'll jump right into it. Okay, We have about 55 minutes left, guys. So we're going to get through all of this stats work and then we'll have a quick chat at the end about a couple of the things I mentioned at the start. So a bit of an overview in statistics. This is going back to year 11 content. There are heaps of different ways that we categorize data. So we're going to have a look at this diagram. We always start with some piece of data. We can then break data down into being either categorical or numerical. Now, what do I mean by this? Categorical data is data that exists in categories, like the color of someone's hair, their eye color, a color of a car, the, color of the shirt they're wearing, the name of their child, their country of origin. It is a category, right? We then break down categorical into nominal and ordinal. Before we do that, let's have a look at numerical. Numerical data is numbers. You can count it. So it's the number of shirts that somebody owns, the number of cars that somebody owns, the number of pets that somebody owns, the number of people in a room, anything that is countable. That's then broken down into discrete and continuous. So when it comes to categorical nominal, think about the N-O, no order of categories. So this is data where the categories do not exist in any intrinsic order. It could be the color of somebody's eyes, the color of their car, the color of their hair. There's no intrinsic order to that. However, ordinal categorical or categorical ordinal is categories that have intrinsic order. So think about the rankings. First, second, third place at a dance competition. A, B, C, D, E, F on a report. Something that has an intrinsic order. Numerical data is broken down into discrete and continuous. Discrete data is data that takes exact numerical values. So you can't have 1.5 children. You can only have 1 or 2 children. So it's an exact whole value. Continuous data is any numerical value within a range. So you can weigh 65.217 kilograms or you can weigh 65.2174 kilograms. Any numerical value within a range. That's numerical continuous. We also have a bunch of different ways of collecting data. We can collect data about every individual in the whole population by doing a census. We have an Australian census that runs every 4 years. I'm sure you guys are familiar with it. That's a census. That's a very uncommon way of collecting data because you have to collect about every individual in the entirety of a population. What we're more likely to see is a sample. Sample is a way of collecting data about a portion of the population. So you might just sample 10 people from each community. A biased sample is data that has been unfairly influenced by the collection process, so it's not truly representative of the population. This might be if we have an interview about whether people like reality TV, but we only interview people who we know like reality TV. That is a biased sample. A self-selected sample is when there's a voluntary response. So say you post a survey on your school forum and people choose to fill it out. Random sampling is when every member of a population has an equal chance of being selected. So you say, I'm going to pick 5 names out of a hat of this class of 20, and the 5 of you are going to fill out the survey. Stratified random sampling is when the sample is made up of random samples taken from subgroups. So you might pick 5 random people from each year 12 class, and they are the subgroups of the year 12 cohort. Systematic sampling is when every member of the population is put in order and then every certain number of person is chosen. So we say, I'm going to put everyone in alphabetical order and every 5th person is going to be chosen. So this is all, like I said, year 11 content. This isn't explicitly tested, but it's going to be at the base of your stats questions. Frequency distribution tables. So we use frequency distribution tables to help us display data. Few different rules. Have a look at this table. What do we notice? Number 1, classes cannot overlap. See how it doesn't say 0 to 1 pet, 1 to 2, 2 to 3, 3 to 4, 4 to 5? Because where would somebody with 4 pets go? Do they go in here? Or do they go in here, right? You can only have classes that do not overlap. For these classes, you would say 10 to 19, 20 to 29, and so forth. Even if a number has no data, if it's included in the set, it must be included in the table. So if they say people were surveyed about whether they had 0 to 6 pets, if no one has 6 pets, you still have to include 6, 0, 0. Each interval must also be the same size. So you can't write 0 to 1, 2 to 7, 8 to 9, because those intervals are not the same size. So this example here shows you the number of pets, a tally of how many people had that number of pet, and the frequency. We write the frequency based on the tally. It's not cumulative yet. I know you guys know what cumulative frequency is. We're going to have a look at it now. That was just frequency. Cumulative frequency is the sum of all of the frequencies of the scores. So let's have a look at this table. It is literally just if you have all the frequency, adding them up and putting them in each column. So 2 is 2, 2 plus 5 is 7, 2 plus 5 plus 4 is 11, 2 plus 5 plus 4 plus 2 is 13, 2 plus 5 plus 4 plus 2 plus 1 is 14. Sum of all of the frequencies of the scores. Relative frequency is the number of times a score occurs as a fraction of the total number of scores. So let's do a question. How many people have the score of 3? Well, there's 4 people who have that score. There's 14 total scores. 4 over 14 is the relative frequency of a score of 3. If you were asked for the percentage relative frequency, you represent it as a percentage. So 4 over 14 in our calculator gives me 0.285. So I would probably say 29%. I'm going to give you guys just a second to screenshot those definitions or to jot them down. Okay, let's have a look at dot plots. Dot plots are super simple. You are just writing your scores along the bottom and placing the relative number of dots above it. So this is an example. In this example, it means that 1, 2, 3, 4, 5, 6, 7 people take 10 minutes to eat breakfast. One person takes 12 minutes. 2 people take 8 minutes. No one takes 6 or 7 minutes, so on and so forth. So stem and leaf plots, you're going to actually imagine stems and leaves. So every number on the left is a stem and every number on the right is a leaf attached to that stem. So it's a really, really easy way of not having to write out the first number of a number every single time. So instead of having to write out 52, 56, 57, 57, 58, you can just write 5, 2, 6, 7, 7, 8. So in this, that's 63, that's 66, that's 10, that's 31, that's 49, so on and so forth. Okay, quick refresher on the rules with our column, line, and bar graphs. Number 1, always double check your horizontal and vertical axis. You have to make sure the correct data is in the correct spot. Have you got your horizontal on your, is your horizontal axis your independent variable? You have to make sure they're labeled as well. You always need to make sure your scale starts at 0, and if it doesn't, you have to have that line that demonstrates that you're going like this. You're skipping 0 and you're starting at 20, for example. I'll show you that in a couple slides. You also need to make sure that the scale of your data is regular and increases by the same amount every time. So you can't write 5, 10, 50, 100. It has to be the same increase between each piece of information. You cannot change your scale halfway through. The two axes can have different scales. So this one could be up by 1 number each time. This one could be up by 50 numbers each time, but they have to be the same on each. So this one can't switch to 50. This one can't switch back to 1. If you do, when you draw your lines, try and use a ruler and make sure that they're exactly following each point. So you don't have like a grapes bar that goes down like this. Okay, frequency histograms and polygons. A histogram is a graph, so it can be a column graph or a bar graph, in which the values of the variable are placed on the horizontal axis and the frequency of the variable is on the vertical axis. So there's no gaps between the columns. What's important is you remember with a frequency histogram, you don't need the gaps. With a column, line, or bar graph, you do need the gaps. With a frequency polygon, that is a line graph that is just made by joining the midpoints of any column in a frequency histogram. You start in the bottom left corner of the first bar and you end in the bottom right corner of the last bar. You hit the top of each bar, and if there's no data, you hit the bottom of the axis. A cumulative frequency histogram is a histogram that uses cumulative frequency on the vertical axis instead of just frequency. So it's always going to be going up, and it demonstrates that this jump to this jump is the amount of people that did this point. It's just adding to this point. So there weren't actually 18 people who had that length. It's just the difference between how many people had this length and how many people had this length. I know it's kind of difficult to understand, but if you need to go back and revise this content, I would recommend doing so sooner rather than later. You'll see in this one, we had a little jump straight to 20, and we indicated that with a line that looks like this. That is allowed, you just have to do that line. A cumulative frequency polygon would be if we drew a histogram and then joined the upper right-hand corners of each column of that histogram. So if it looked something like this, the cumulative frequency histogram would just look like that. Pareto charts follow the 80-20 rule. So basically 80% of the study you do will allow you to achieve about 20% of the marks that you do in the final exam. The other 80% of your marks are going to come from 20% of the studying you do, which is more likely to be that really active study like the practice papers. They combine a vertical column graph and a cumulative relative frequency graph. So this line is showing you the cumulative relative frequency as we follow this line. So if we go down to 80% of all defects come from button defect, pocket defect, and a little bit of collar defect. So cuff defect and sleeve defect are not responsible for 80% of problems. Okay, we've covered our Year 11 content. We now have enough time to get through all of our Year 12 content. We're going to look at bivariate data analysis, which is scatter plots, the correlation coefficient, the line of best fit, and the least squares line of best fit. And we're also going to look at normal distribution, which is the properties. We're going to look at the properties of normal distribution, and we're going to talk about z-scores and interpreting z-scores. The first thing I wanted to draw your attention to is stats has a whole section on the formula sheet. All of this stuff is related to normal distribution, the whole section. So this section is covered on the summary sheet, but you need to know what it actually means. Okay, scatter plots. Scatter plots are used to determine the relationship between two numerical variables. So in completing bivariate data analysis, we'll collect data for two different variables and then we display it in a table. So we might look at somebody's height and weight and then we determine, is there a relationship present between those two variables? Then we determine, are they independent or dependent variables? Is it a strong relationship? We can answer a bunch of questions. This is what a scatter plot looks like. It is an axis, a vertical and a horizontal with a bunch of dots. Each dot represents a piece of information. So this one is like almost 4-4. So to describe patterns, we're going to use 4 different pieces of information. Is it positive linear, negative linear, non-linear, or no correlation? So if there's a linear relationship, the dots will approximately be in a straight line. So see how here the dots are it's pretty hard to miss that they're going up in a positive manner. There is a positive linear relationship. This is a non-linear relationship because there's no straight line. If there are a bunch of dots in here as well, it would still be non-linear. As long as no line is created that goes in any direction, it is going to be non-linear. Now this is a positive linear pattern because the dots are generally going from the bottom left to the top right. This is a negative linear pattern because the dots are generally going from the top left to the bottom right. Just like how this would be a positive gradient and this would be a negative gradient. So this is no correlation because there is no way to draw a line or to put a curve in that represents these dots. No correlation. This is non-linear pattern because there seems to be some correlation, but it is nowhere near being a straight line. So once we've established if it's a positive, negative, non-linear, or no correlation, we then describe the strength. So we add a second term in. So it's positive something, negative something. It can be strong, moderate, or weak. Strong correlation is where the dots are very much centered together. Moderate is where you could probably draw a nice large sized rectangle around them. And weak is when it's very weak that they're headed in the same direction. If we only had a couple dots up here and up here, we would say no correlation. But because it generally appears that they're headed in this direction, it's a very weak one, we still say there's a weak correlation. So example question, what is the strength of the linear relationship displayed below? I'm going to give you about 20 seconds to pop it in the chat. Okay, first thing you want to look at, is it strong, weak, or no correlation? I'm going to say it's strong because the dots are all very much close together. Is it a positive, negative? It's going to be a positive because the correlation is headed from the bottom left to the top right. So it's a strong positive correlation. Here's an example question. The table below compares a father's height and his daughter's height in centimeters measured over 10 years. Draw a scatter plot to represent this data. Describe the correlation between these two variables. So let's have a look at our solutions. The first thing I would do is label each axis. So the father's height is going to be our independent variable because he is the one who is just changing on his own. The question is the daughter's height dependent on the father's? So we're going to draw out equal intervals, 155 plus 2.5 plus 2.5. So we're going with plus 2.5 as our intervals for the father. Now the daughter grows a lot more, so we're going to go with intervals of 10 for her. So once we've drawn that out, I'm going to give you guys a second. We're then going to talk about how we plot our dots. Okay, I know that it's not enough time for you guys to draw that on, but I need to keep moving and keep you guys, I don't want to give you any silence for too long. How do we draw a dot? So let's have a look here. Father's height 157, daughter's height 95. This would be 157 for the father and 95 for the daughter. So we draw a dot there. We're going to continue drawing on our dots until we filled in all, how many data points did we have? All 10 of our data points. Now we need to figure out if there's a correlation. So let's see, all of our data goes in this direction, right? So it's going to be positive. And I would say that it's generally quite a strong correlation. So we would say strong positive correlation. As the father's height increases, so does his daughter's height. However, once the father reaches his maximum height, this becomes stagnant. Now, there's a much better way to describe the strength of correlation without having to depend on words. We can actually just use a number. Now, this is called the correlation coefficient. You might also see it be called the Pearson's correlation coefficient, but it's called the correlation coefficient. What is the correlation coefficient? So to quantify the strength of a linear association, so i.e. if we're determining a number which represents the strength of the relationship between two variables, we're going to use Pearson's correlation coefficient. Now, here's a really confusing bit. You would hope that it's using the letter C or P. No. Pearson's correlation coefficient is demonstrated by the letter R. So Pearson's correlation coefficient is R. Now, when you go into your calculator, and we'll talk about this in a sec, you have a mode button. Mode 2, stats. 2, you then go into 2 plus 2, which is A plus BX. You will have the option to hit shift 1.5 when you need, sorry, this is going to make more sense in a second. In your calculator, when you go to a certain screen, it says 3R. R in your calculator is Pearson's correlation coefficient. So it's not just on your exam or on your paper. Your calculator, if you're using the correct one for the HSC, will have 3R for Pearson's correlation coefficient. So the correlation coefficient, to explain a little bit further, is a range. So let's imagine we have a little graph, a little bar here. This is perfect positive. This is a straight line positive. This is perfect negative, straight line negative. This is 0, where nothing is correlated to each other. This is 0.5, where things are getting pretty close. And this is negative 0.5, where things are getting fairly close as we go down. It can be perfect positive, perfect negative, or anywhere in between. Basically, the closer you get to 0, the closer you are to no correlation. The further away you get, the closer you are to perfect correlation, perfect negative or perfect positive. So we're going to use this table as a guide of how to describe it, because not only do you need to use the table, but you need to use the words associated with each number to describe correlation. So you can't just drop the whole strong, moderate, weak thing. You're going to use the number and the word strong, moderate, weak. So it could be a strong positive correlation, which would mean it's between 0.8 to 1. Moderate positive would be 0.5 to 0.8. Weak positive would be 0.3 to 0.5, and no correlation will be 0 to 0.3. A strong negative will be negative 0.8 to negative 1. A moderate negative will be negative 0.5 to negative 0.8. A weak negative will be negative 0.3 to negative 0.5. And no correlation will be negative 0, or will be 0 to negative 0.3. So here's a key point. You are only expected to do this via our beautiful calculators. There is no way for you to use the Pearson's correlation coefficient without using a calculator to work it out. They are not expecting you to be able to do that. In fact, they're not going to teach you how to do that because it's very, very complicated. So we need to note the meaning of the relationships. If it's positive correlation between two things, it means that both things increase or decrease at the same time. Both of the people's heights go up at the same time. Both of the weights go down at the same time. Both of the cars drive at the same speed. Whatever it is, there is an increase or decrease at the same time between both variables. If there is no correlation or zero correlation, there is no relationship between the variables. So as this person's height increases, this person's weight stays stagnant. There is no correlation. If there's a negative correlation, one variable increases while the other variable decreases. My weight goes up as my amount of food intake goes down. There's a negative correlation there. Okay, this is the bit we're going to take a minute on to get you guys very much understanding this. To calculate the correlation coefficient given a data set, first things first, screenshot this, but I'm going to show you how to do it on your calculator. Okay, I know it's a bit hard to see, but follow these steps. Number one, hit on. Blank screen on your calculator. I'm not kidding you guys. This is something you need to know for your final exam. If you do not know this, you will fail this question. They are not going to give you instructions. You cannot carry these results or these steps into the exam. On. Okay, mode. Mode on my calculator is next to on. I don't know where it is on yours. It should be around the top. Mode. Then you're going to hit, you'll see three options. 1 comp, 2 stat, 3 verif. You're going to hit 2 for stat. You're going to get a bunch of different options. Number 2 should be a plus bx. You're going to hit 2. You should get something that looks like this. 2 columns, x, y, and a bunch of 1, 2, 3. You can put data in. This is where you put your data in. Let's say x is the height of a person and b is the weight of the person. I'm going to put 3 pieces of data in. I'm going to put the height of 180 equals, sign to enter it, a weight of 60. I'm going to put, you fill out one column first. So 180, and the next height is going to be 160, and the next height is going to be 140. Then I'm going to move with my little button here. I'm going to move myself over to the other column and put myself in the first position so I can fill in the data. I'm going to say the weight of this person is 70, the next weight is 60, the next weight is 50. Now I have 3 pieces of data in my 2 columns. Now I'm just going to hit on. The data is still in there. It's chilling in the calculator, but we're going to hit on or AC, whatever you want to hit. Now I'm going to hit AC shift 1. I've hit AC shift 1. I have type data sum var reg min max. I'm going to hit 5 for reg. This means regression, regression. 5. Now I have 1 is A, 2 is B, 3 is R, 4 is X, and 5 is Y. I'm going to hit 3 to get the Pearson's correlation coefficient. It's going to say R. I'm going to hit equal 1. I had perfect correlation between my 2 variables. Okay, we're going to do that one more time. Put your calculator, hit mode, go back to 1. Mode 1. I'm going to give you guys a second. Okay, one more time. Mode. We're going to hit mode. 2 for stats. 2 for A plus BX. We're going to have some data. I want you to do the following. X is 190 equals 170 equals 150 equals. Take your cursor or your little controller, move it to the top of the Y column. I want you to do 60 equals 40 equals 20 equals. I want you to hit on or AC. I want you to hit shift 1, 5 for regression, 3 for correlation coefficient equals 1. Perfect positive correlation. Okay, 20 seconds, screenshot that. Put your calculator back to the base of stats mode. Once you've got all your answers, you just hit on and then go back to mode 2, 2, and you go back to your little table. Okay, example question. A teacher measured her students' heart rate in an examination and their height in centimeters and presented the information in a table. Calculate the value of the correlation coefficient correct to 4 decimal places. All right, so heart rate is going to be our X, height is going to be our H, our Y. So let's get our calculators out, get our little tables. Okay, 61, you're going to hit 61 equals, 63 equals, 63 equals, 67 equals, 69 equals, 71 equals, 72 equals, 75 equals, 78 equals. So now we have 9 pieces of information sitting in our little X column. We're going to move our little cursor over to the Y column, pop it to the top. Now we're going to write down our height, 154. After everyone you hit equals, 172, 151, 163, 180, 165, 168, 170, 158. An important thing to double check is that your data is ending in the same line. So you shouldn't have one extra X or one extra Y. I'm going to give you guys 10 seconds to catch up. Have all your data entered, and I want you to hit on or AC. Okay, once you've done that, we're going to do shift or on or off or what, hit on or AC, one of the two buttons. Shift 1, 5 for regression, and you should get R equals 0.25556 for blah, 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 blah. Right there. The solution to the closest 4 decimal places is 0.2556. We have to round up the 5 because it was 25556, which means we round that up to a 6. Okay, I think you guys should be following. I went through that nice and slow. We're going to move on to line of best fit. So after drawing a scatter plot, using the value of the ordered pairs, we can now draw a line of best fit. If the points have a linear correlation, we can approximate a straight line graph that relates to 2 variables. Now, this is called linear regression. The aim of the linear regression is to model what that line would look like if we used our point intercept formula, which is our gradient intercept y equals mx plus c. So before we draw a line of best fit, we need some form of data. So we use these points to guesstimate a line, and then that's our line of best fit. Use the points below, draw a scatter plot and a line of best fit. So 0, 6, 224, 339, 444, 559, 664, 779, 884. We've plotted all of those in. These were our y, these were our x. These all been plotted in. As we can see, the points do not exactly line up. So therefore, we're going to draw a line of best fit. So students often find this quite hard to do. The line should pass through as many points as possible. And if it doesn't pass directly through a point, you put the same number of points on either side of the line. So 2 above, 2 below, and it passes through 4. So let's have a look at this line of best fit. It passes through 1, 2, 3 points. And there are 1, 2, 3 points below and 1, 2, 3 points above. They're very close to the line, but there's 3 below and 3 above. So if we go back to this question, we would want to draw our line and see how in this one it doesn't have to start from 0. We'd want to draw our line something like, and this is very hard to do straight, on a computer. Something like this. So we have, okay, it'd probably be better going a bit down this way, but you can understand it's hard to do. But we would try and go through maybe this point, this point, this point, and this point, and then we've got two below, or we'd have, sorry, two above, two below if we try and get through these points. It's very hard to do. I would recommend having some practice on paper. It's very hard to do on a computer, I'm saying, but you just have to make sure you have the same number below and the same number above, and as many through the line as possible. We now need to learn about least squares line of best fit. This is quite complicated. It's the least squares line of best fit formula. It represents the straight line equation when it's trying to find that formula. We just use y equals mx plus c. But it only requires us to do it using our calculators. In order to find the line, we must use the given data set, so the height and weight or whatever it was, and a particular statistics mode to calculate the gradient and the y-intercept. So we're going to do this equation. Let's go back to our calculators. Let's hit on, mode 2, 2. We have our little table. Sorry, sometimes I have to throw my calculator to get the screen to show up. I've had this one since year 7, which was 2015. I was in year 7. So it's almost 10 years old. Okay, so we're going to add in our heights first. 150, 152, 155, 160, 165, 167, 169. Move our cursor over to y, to the top of y. 25 equals 23 equals 28, 26, 30, 29, 27. We added all of that in. Just hit AC or on. Now we go to, we enter our data. We go AC, we go shift 1, and then we go 5 for regression. We have 5 different options. Now, we need to find what B equals, because B is our gradient and A is our y-intercept. So our formula looks like y equals bx plus A. So the gradient is B. So we're going to hit 2 for B equals. Now B should equal for you 0.22. I have 0.22, 0.46588902, 0.22. Now I'm going to get back to on, shift 1, 5 for regression. I'm going to hit 1 for A equals, and I got A equals negative 8.354409318, so negative 8.35. Now I have that. We're going to use our least squares line of best fit for y equals mx plus c. So we're going to put in y was our foot length and h was our height. So we're going to change them to their actual measurements. 0.22 was our b, which is our gradient, and negative 8.35 was our y-intercept. So now we have a formula where we can answer questions. What is the expected foot length of a student given that their height is 180 centimeters? So 180 is our height. We plug it into 0.22, 180 minus 8.35, 31.25 centimeters for a foot length. Okay, we're going to have a look at normal distribution before we finish up. We haven't got too much longer left, guys. Really good job so far. In a normal distribution, the distribution of data is symmetrical about the mean. So let's just kind of backtrack. We have something in data called the mean, right? The mean is the average. The mean, median, mode, all of that stuff represents the average, the middle, the most popular, what's happening at the middle of our data. Normal distribution, which is pictured on our formula sheet, is if you have normal, mathematically normal distribution of data, the most normal way it could be distributed. The mean and median are approximately equal, and a bell-shaped curve is going to represent normal distribution. So this is what it looks like. It's based on something called the empirical rule. So what this is based on is another concept called z-scores. So you have to understand these z-scores. When we look at normal distribution, 0 is the mean. So if the mean in any given score is 10, the average age of a person in the football team is 10. Well, let's say the age goes up by 6 months. So this is 10 and a half, this is 9 and a half. 34% of people will be somewhere between -1 and 0 z-score. 34% of people will be between 0 and 1 z-score. So 68% of data will generally be between -1 and 1, which is one standard deviation above the mean and one standard deviation below the mean. So z-scores are representing a number of standard deviations away from the mean. If you're not following, it's okay. You'll have plenty of time to revise this, but in the interest of time, I'm just going to use the words that you should understand or should try and understand by now. If you haven't covered it in class yet, that's fine, you will cover this. If you have, hopefully this is jogging your memory. These are the empirical rules. 68% of data will be between -1 and 1. 95% of data will then be between -2 and 2. 99.7% of data will be between -3 and 3. Only an extra 0.15% is either side of +3 or -3. Now, on your formula sheet, you get the graph of z-scores, and it says approximately 68% of scores have z-scores between -1 and 1. Approximately 95% of scores have z-scores between -2 and 2. Approximately 99.7% of scores have z-scores between -3 and 3. Now, you have to remember that breaks down into 34, 34, 13.5, 2.35, 0.15. I would recommend that as soon as you get in the exam, you write them on and you remember them for that formula sheet. The empirical rule is aiming to help you remember the percentages. So the rule is also known as 68, 95, 99.7. So if you remember those three numbers, you should be okay. You can always remember that you've got to halve them as well. So 34, 13.5, 2.35, and 0.15. Okay, so what is a z-score? A z-score, which is a standardized score, is a tool of comparison in a normal distribution. So it is the number of standard deviations that the score is from the mean. So to calculate the z-score, we use the score minus the mean over the standard deviation. So say I got a 50 on my maths exam. That's my score. The mean was a 45 and the standard deviation was a 5. 50 minus 45 over 5 gives me 1. I was one standard deviation above the mean, which means my z-score is 1, positive 1. So on this graph, I would be here. Now, we can also flip this formula around. I think I go through this with you, but if I don't, we can flip this formula around to find our score by rearranging the formula. So how would we do that? If we want to find our score, we're going to times both sides by standard deviation to get it on its own. So z-score times standard deviation equals my score minus the mean. And I'm going to add the mean to the other side to get it on its own. So z-score times standard deviation plus the mean equals my score. The heights of Year 12 girls are normally distributed with a mean of 165 centimeters and a standard deviation of 5.5 centimeters. What is the z-score for a height of 154 centimeters? Okay, so z-score equals my score minus the mean over the standard deviation. My score was 154 centimeters. The mean was 165 centimeters. The standard deviation, 5.5. Now this is an important note. If you need to go back to stats mode, hit mode 1 for comp. Then you're going to hit fraction. 154 minus 165 over 5.5. I have a standard deviation of -2. This means I am 2 standard deviations below the mean. Okay, and a z-score of 0 means your score is equal to the mean. A z-score of 1 is your 1 standard deviation above the mean. A z-score of -1 is your 1 standard deviation below the mean. The larger the z-score, the further it is from the mean of the data. So this applies to both negative and positive. Think of your correlation coefficient. The further you get from 0, the more perfect it becomes. The further you get from a 0 z-score, the further you're getting from the mean. So we're going to do a question. After sitting an exam, a university student is told they have a z-score of 0. The marks in the test were normally distributed with a mean of 65.5 and a standard deviation of 4.8. What mark did the student achieve? Now, because they have a score of 0, we don't actually have to work it out. We just know the mean was 65.5. They had a score of 0, a z-score of 0. They got the mark 65.5. But for the sake of it, let's do the question. Z-score equals their mark was 65.5. The mean was 65.5. And there was a standard deviation of 4.8. 65.5 minus 65.5 over 4.8, we get 0. We can also rejig our formula and check that we're right by going the z-score 0 times the standard deviation, which was 4.8, minus the mean, which was 65.5, and make sure we put our brackets in. And we should get, unless we've rearranged our formula incorrectly, you should get 0 if you put it in correctly. Yes, okay. So 65.5, we need to move that out of the way. Willow is in year 11 and has completed 3 out of 4 English assessment tasks. A summary of her results is shown below. What is her Z-score in task 3? Okay, her mark in task 1 was 15, her mark in task 2 was 24, her mark in task 3 was 19. The mean of task 1 was 14, she had a standard deviation of 3. The mean in task 2, we don't know, and she had a standard deviation of 4. The mean in task 3 was 23, she had a standard deviation of 2. Her Z-score is going to be her score, 19, times, I'm forgetting my formula, hang on. 19 minus the mean, which was 23, standard deviation over 2. So we go 19 minus 23 over 2, and we get a Z-score of -2. -2. We can also use Z-scores to compare scores that are in the same data set. So when we have 2 Z-scores, we then compare them against the mean. The HSC marks for standard maths are normally distributed. This is always our key, normally distributed. Mean of 67, which is a Z-score of 0, standard deviation of 7. Zach's mark was 94. Barbara's Z-score was 3. She's claiming she got a higher mark. So is her calculation, or is her claim correct? So let's find out what Zach's Z-score was, and then we can figure out who had the higher mark. So Zach's Z-score is going to be his mark, 94, minus the mean of 67 over a standard deviation of 7. 94 minus 67 over 7 is 3.85, which means he had a Z-score of 3.85. Now, because it's a positive and it's higher than 3, Barbara's claim is not correct. So we did this by finding Zach's Z-score. We could also do this the other way around by finding Barbara's score. So we know she got a score of 3, the mean was 67, and the standard deviation is 7. We then need to find her score. So we rearrange our formula, 21, so we do 7 times 3, 21 equals x minus 67. We add 67 to both sides, x equals 88. So her score in the exam was 88, but Zach's score was 94. Now, this was the 2020 HSC question that was on my exam. It was quite hard, so I'm going to show you the working out here instead. Okay, the intelligence quotient scores for adults in City A are normally distributed with a mean of 108 and a standard deviation of 10. So we need to find the first thing, well, I'll read you the question first and I'll explain what we're doing. The IQ score for adults in City B are normally distributed with a mean of 112 and a standard deviation of 16. So the first thing we're going to do is find our 2 Z-scores. So City A Z-score is going to be x minus 108 over 10. A City B Z-score is going to be x minus 112 over 16. Simon, who lives in City A, moves to City B. The Z-score corresponding to his IQ score in A is the same as the Z-score corresponding to his IQ score in City B, which means that these 2 x's have to equal the same thing. So we're going to form an equation. X minus 108 over 10 has to equal x minus 112 over 16. So we're going to turn it into 2 equations by going 10x minus 112, which is going on this side, and then 16x minus 108. And we're going to create two equations. And now we just need to move each part of the equation over. So we subtract 1120 from 1728, 608. We get 6x and we subtract 10 from 16x. 6x equals 608. X equals 101.3. So Simon's IQ has to be 101.3. Now it is a little tricky to grasp. So I'm going to go back, have a look at the question again. First Z-score for city A. Z-score equals score minus 108, standard deviation of 10. Second Z-score, score minus 112, standard deviation of 16. If you can put together those two formulas, you're on the right track. I wouldn't be as concerned about answering the question because it is quite difficult and you just need to be able to answer it by the HSC. But as long as you can put together those two equations, you should be able to move forward with the question. Okay, we are coming up to our final 10 minutes here. So I'm going to talk about a couple different things. Let me know in the chat, what is your biggest fear or concern as you move through year 12? We are done with content now. So if you have any content questions, drop them in the chat. I will try to get to them written. I obviously can't answer them for you right now, but I will try and answer them for you in the chat. If you have a question, please let me know the slide number and I will go back to that slide on my own end and try and answer that question for you. It is a little bit hard for me to do that over the chat, so just be conscious of delays and be conscious I maybe can't give you a fully fledged answer, but let me know by using a slide number and a topic number and even a question number. That would be helpful. At the same time, drop in the chat, what is your biggest fear or concern as you move through year 12? I'm going to hit some of the main ones I see from students. I'm just going to have a water break while you guys do that. I've been talking for many, many hours. Okay, the first thing that I see students really freaking out about is, what if I don't get the right ATAR? What if I fail? What if I get a really bad ATAR? What if I don't get into uni? Couple things that I want to hit there. Number one, that's going to be a fear for everyone. As confident as you are, as much as you say you don't care, if you're one of those people, everyone's going to be a little bit nervous when they open their ATAR. Most people, at least. There are some people who genuinely don't care, and I admire them for that. But it's fine if you're a little bit nervous about your ATAR. It's fine if you're stressed about it. That's it, to be expected. The first thing I would say is a lot of people catastrophize. It's probably not going to be as bad as you think it's going to be. If it is, it is. And the only person who's responsible for that is ultimately, unless it's been intervening factors, you, right? And that's fine. If you are fine with what you get and you're happy with what you get, then you should be proud of what you get. But if you know that you want to get a certain mark and you don't want to disappoint yourself, then you need to kind of make a deal with yourself about how hard you're willing to work. It is very unlikely that it's going to go horrifically. If it does, it does, but there's a lot of things we can do to prevent that. What I would say is, number one, if you don't get the ATAR that you need, say you need a certain ATAR to get to a certain course, or you need a certain ATAR for something. I know everyone's told you this and it doesn't matter to you right now, but it is not going to stop you from getting where you need to go. It is not the end of the world. ATAR is great. It opens windows, it opens doors, it opens paths, but it doesn't close anything off. Everything is still accessible. It might not be accessible in the way you planned on it being accessible, but it is still accessible. It might mean you take an extra 6 months to graduate uni. It might mean you have to transfer unis or you have to transfer courses once you're in. It does not mean that you cannot go and do the same degree or the same course that everybody who got 99.95 is doing. If you want to do law and you get a 65 ATAR, within a year, you can be in a law degree at UNSW. If you go to UNSW, this is the uni I go to, you get into a course that has a 60. If you get a good WAM, weighted average mark, if you get, above, from my understanding, a 70 or so average, you will be in the law degree by the following year, with everybody else who had to get the 96. So everything is accessible if you commit to working hard enough in uni, or if you commit to getting the ATAR that you need. Everything is going to be accessible. The ATAR opens doors. It does not permanently close them. So that is something to be assured of. It is better that you look after yourself this year and you don't destroy yourself over this to get the ATAR you need, rather than taking an extra 6 months to graduate uni, or taking an extra course that you have to transfer from. It is very unlikely it is going to go as poorly as you think it is. The next thing I would say is motivation. A lot of students come to me and they say, I can't stay motivated, I don't care enough, I've hit the wall. Very expected. It happens to everyone at different times. I was completely burnt out with about 4 weeks to go. So about 4 weeks before the HSC hit, I'd been studying my ass off, and I just lost it. I could not do it anymore. I remember crying to my mum saying, I'm done, I'm over it, I don't care anymore. And I reached a level of unbothered that I could only dream of reaching again. It was the day before the HSC, multiple days before English. I did not pick up a pen. I sat on my phone 12 hours a day in bed, ate, did nothing, lay down, did not pick up a pen, did not open my laptop. I truly did not care. And I still managed to get all my band sixes because I had put in the work throughout the year. And this is something my mum reminded me when I was really stressed. She said, you've done all the groundwork. You've done all the work. You can revise now, but you've done all of the work. You're done, right? You get to the exams, you're done. You can't do any more. And this is the tricky thing about year 12. You could always do more. You could always do another practice paper. You could always revise another quote. You could always read another textbook. You can always do more. But that more is not going to get you any further. You cap out. There is a cap where all you're going to do is continue burning yourself out. And it's really important to remember that. You just have to strike a healthy median of putting in the effort and not burning out. You're revising enough, but you're not over revising. There's only so much room up here, guys. You can't over revise. You can't fill it up. You need room for other things. You need room for yourself, for your social life, for your family, for your friends. So when it comes to motivation, how do you stay motivated? Setting goals is helpful. I didn't necessarily have a goal ATAR because I didn't necessarily have a goal course. I kind of had a personal goal of what I thought would make me happy. And ultimately, I wasn't made happy by my ATAR. I was made happy by the fact that I felt like my teachers were proud of me and I felt like I did the best I could. And year 12 was a very challenging year for me personally. So I was very, very proud that I got through it considering what had been going on in my life. And that's a lot what happens for a lot of students is they go through really tough stuff in year 12. And it was more impressive to me that I got through the hardest year of my life, especially with COVID starting in March of my year 12. So much went down that I was really, really proud that I got through and I got the mark I got. And I impressed my teachers and they were proud of me. And I made my family proud, all of that. If that doesn't manifest for you, I know this is kind of going 100 different ways, but the point of what I'm trying to say is that is not the end of it. And that is not the be all and end all. Your life does not cap at the HSC. In fact, it is such a blip. I've only been out of year 12 for just over 2 years. It feels like I've been out for 20. So much good comes after year 12 that this hard slog of what you have in front of you is really just you working hard for your future self. I thank myself all the time for how much hard work I put in year 12 to get myself into a good uni, to get myself into a good course, and to set myself up for lots of successes after high school. So think of yourself as doing yourself a service for the future. You're working hard for yourself, not for other people, but for yourself. Now, if you experience a lot of procrastination, which is another thing that I find a lot of students come to me with questions on. Number one, a really, really good thing if you have digital procrastination, if you are always on your phone or your laptop doing stuff you shouldn't be doing. I love this app called Forest. It plants an imaginary tree. The tree grows. Say you want to study for 90 minutes. You can't go on your phone unless you're looking at your tree. You can't go on any other apps. This is my Forest for the year if anyone's interested. I've grown quite a lot of trees. I've studied for 25 hours and 50 minutes this year. I've planted 51 trees and I don't use it that often because often I find that it's actually, I don't even need it anymore. I also have my focused settings really tailored on my phone. So I have like work, uni, personal, and I use them very specifically. And I have different apps programmed for different focus settings of what I can receive notifications on. The other thing I would say is try and break your work down into minute chunks. So when I have an assessment coming up, and I can actually show you guys this. This was a midterm I had coming up. Number 1 was reread the midterm. Number 2, create a document. Number 3 was read the question forum. Number 4 was annotate the problem question. Now, each of those tasks only took about 3, 4, 5 minutes, but making them individual tasks meant that when I came and sat down to do my work, I wasn't confronted by a task that said, do midterm. It was create a document, read a forum, annotate a problem question, reread the problem question. It's a lot more easy to achieve when you break down your work into manageable chunks. Now, I know that's lots of different pieces of information, but I don't have much longer with you guys, so I wanted to run through one thing. This is what I give to all my students. Step number 1 in approaching this next 6 months is accepting it will be stressful and not listening to anybody who tells you it won't be. It is going to be stressful, it is going to be hard, but that is what makes it worth it, because you get through it and you do a good job at it. And I know that this all sounds scary, but you guys are well into it. You know this by now. You're going to be completely fine. It does not have to dominate your life. The pieces of information I would give you that are very important. Try your best to stay up to date. When you do fall behind, prioritize your work by cutting your homework in half and only attempting the harder questions, and try your very best to plan revisions weeks out from exams. 4 weeks out, you want to finalize notes. 3 weeks out, you want to attempt the exams untimed with notes. 2 weeks out, you want to attempt them timed with a few notes, and 1 week out, you want to attempt them in full exam conditions. This is all easier said than done. This is the advice I would highly, highly, highly recommend. If you have any last minute questions, pop them in the chat. I've got about 30 seconds left with you guys, but I just wanted to say another big shout out. If you need any help, ATAR Notes free resources, study notes, lectures, discussions, videos, newsletters, the ATAR calculator articles, heaps more. For our paid resources, you can check out TuteSmart, which is our private and our class tutoring, Ed Unlimited, and our study guides, which you can purchase. Head to atarnotes.com/register. Thank you guys so much for being here with me today. Thank you for talking to me in the chat. Thank you for being here with me watching. I hope you found this helpful. I hope you've learned something of value. You can always come back to the video and download the slides if you need any further help. You guys have got this. I believe in you. Hopefully I'll see you at our July lecture series right before your trials. But best of luck, and hopefully I see you guys next time. Have a great rest of your day, guys. See you.